All right, ladies and gentlemen, here we are at Unit 7 on circles. So today we're just going to talk about some circle basics and stuff that should be pretty familiar for area and circumference. Okay, so first, the definition of a circle is all points are equidistant from a given point. And that given point is called the circle or the center. So like J here is the center. So then we call this circle J, and we draw a circle with a little dot in the middle so we don't mistake it as an O, and then J, circle J. Okay, then we also have our radius. It's a segment with one endpoint on the center and one endpoint on the circle. So a segment with one endpoint on the circle and one at the center. So for example, J to F is a radius. Okay, but I could also say like J to C is a radius. Well, I could say JD is a radius. Lots of options for a radius. JA is a radius. Okay, so I'm going to mark that as a radius. And then I'm going to go down on the bottom, the diameter. It's a segment that goes through the center with both endpoints on the circle. So a segment that goes through the center and endpoints on the circle. So we have here GD is a diameter. The diameter is twice the radius, and the radius is half of the diameter. Okay, and then we have this other one that's new to us that's called a chord. It's a segment whose endpoints are on the circle. That should say whose. Okay, so a segment that is going to be endpoints on the circle would be something like AC. Okay. Your diameter is your longest chord in your circle. So some circle basics terms for you. So let's go ahead and identify these on the next slide. So it says identify the parts of the circles below. So the name, so we're going to name this. This is going to be named circle P. Okay, so a radius, we actually have 3 radii here. Radii is plural for radius. Okay, PL, PN, and PM are all radii. Okay. And again, we start with the center first and then go out to the edge. The diameter is LN, so it goes all the way across. It could also be NL, both are the same. And then chord, we would have MN or NM. Either one is fine for that. All right, so if QV is 4, what's the diameter of the circle? So QV is a radius, so that's half of it. So my diameter is 8. Then it says if TU is 14 feet, what is the radius? Well, the 14 goes for the whole way across, so that means my radius is 7. It's only half of that. Okay, so let's go ahead to the next side of your notes and talk about parts of a circle. Okay, or not, pairs of circles, sorry. We have congruent circles. Excuse me. So that's where you have radii that are congruent. And then we have concentric circles. So coplanar circles that have the same center. So what are some real world examples for each type of circle? Okay, so congruent circles would be things like, hey, wheels on your vehicle. That's a perfect one. Circles, you guys all know the crates I have around in my room. The circles that are there, those are congruent circles. Then we have concentric circles. Those are coplanar so that they are one nestled inside the other. Things like if you look at a DVD, those have concentric circles. So the outside of the DVD and the center. How about the rings in a tree? Those are concentric circles. All right. Then let's talk about circumference and area of a circle. Circumference, we have 2 pi r, so 2 times pi times the radius, or because the radius or the diameter is twice the radius, we can say pi d, so that diameter times pi. Area for us is pi times the radius squared. Both of these formulas should look familiar to you. You have seen them before. Circles generally are something that you cover in late elementary, middle school times. All right, so find the circumference of a circle with a radius of 2.5 centimeters. So circumference formula, they give us the radius, so we might as well use our 2 pi r. And so I'm just going to plug in my 2.5 for that. Now it asks for exact and for rounded. So exact is when we leave pi in our answer. So we're going to take 2 times the 2.5 and we get 5 pi. That is an exact answer. Anytime that you have a decimal and then you do something with that, that's going to be a rounded. Okay, and I expect you to use the actual pi button to do these, not just 3.14. If you do 3.14, most of the time we're going to end up similar, but there will be times that we are different. Okay, so if we do this, we get 15.7. Okay, so our next one gives us our diameter of 16 feet. So we're just going to use our pi d, and so we'll just put the 16 in front of the pi. So 16 pi is my exact. Grab those calculators and type in 16 and the actual pi, and we get 50.3. All right, so this time it says find the radius if the circumference is 36 pi. So circumference, we have to find the radius, so we're going to use our 2 pi r to help us find that. And the circumference is 36 pi. So the first thing I see is that there's a pi on each side, so I'm just going to cancel those to make it easier for us. So 2r equals 36. So go ahead and divide both sides by 2, and we get r equals 18. Here it's asking us for the circumference, but we have this circle inside of a square, okay? And so they show us that the length of the square is 10. That means that also our diameter is 10 because that goes from edge to edge. So here I'm just going to use my diameter times pi and give it 10 pi. See how easy that is to give that exact answer? Find the area if the diameter is 10. So now we're going to use our area formula, which is pi r squared. So my diameter is 10, so that means my radius is 5. So I have pi times 5 squared, and 5 squared gives me 25. So let's just leave it as 25 pi because it doesn't specify, and so I'd much rather take the easy way out. Okay, find the area if the radius is 2 square root of 2. So we have pi times 2 square root of 2 squared. Now, because there's not a multiplication or division inside my parentheses, I can distribute that squared to both of those terms. So 2 squared gives me 4. And then this right here, the square root of 2 squared, those are going to cancel. So we get just a plain old 2. So we end up with 8 pi for that answer. Find the radius if the area is 25 pi meters squared. So pi times r squared is equal to 25 pi. So again, I see a pi on both sides, so I'm going to simplify by canceling that. So I get r squared equals 25. Well, to undo a square, I'm going to take the square root on both sides. So r equals 5. Okay, this one again asks us for the area, but we are given the side of the square or the rectangle is 14. So that means that my diameter is 14. But if we're talking area, we want radius. So my radius is, oops, not 5. So half of 14 is 7. So I'm going to put pi times 7 squared, and 7 squared is 49. Okay, so we saw a few of those circles inside squares, and so those are inscribed circles and polygons. So polygons are inscribed in a circle if it's inside the circle. So inscribed means that all of its vertices lie on the circle. So if we look at this diagram to the right, we would say, we could say polygon LMNP is inscribed in circle K. That polygon is inside the circle. So then the other word we have here is circumscribed. Please be careful when you are saying that. If you say it incorrectly, we're going to have a chat. Circumscribed, excuse me. Circles are circumscribed about the polygon if it contains all the vertices of the polygon. So this one is going to talk about the circle that's about the polygon, so meaning around the polygon. So we would say circle K is circumscribed about or around polygon LMNP. So the circle is circumscribed and the polygon is inscribed. So let's go ahead and look here at the next problem. It says a square with a side length of 9 inches is inscribed in circle J. So the square is inside the circle. Find the exact circumference of circle J. So to be a circumference, we need the diameter or the radius. But here we are only given this square side length. So then that means that this is also 9. So let's go ahead and find that hypotenuse first. Well, geez, how are we going to do that? Well, you can use Pythagorean theorem, or this is a square, so this is a 45, 45, 90. So I know that my hypotenuse, or my diameter, is 9 times the square root of 2. So that's my diameter, okay? So, because it says find the exact circumference, so we don't want to have any decimals with that. So we want my radius. My radius is half that. I know we're going to have a little decimal there. Woo! Where'd it go? Where'd it go? All right, so my radius is 4.5 square root of 2. So let's go ahead and we are finding the exact circumference. Oh, circumference can use diameter. I don't know why I needed to even find my radius. Circumference, we can say d pi. So my circumference is 9 square root of 2. Make sure the pi is written outside of that square root. There is my exact square root, or exact circumference. Find the exact circumference of a circle with circumscribed square with sides 10 feet long. We've already been looking at a few of these problems. We know that this means that my diameter is 10. And if I want the exact circumference, I'm just going to say 10 pi. All right. There we have it, ladies and gentlemen. And your homework is your 7-1 worksheet. See ya.